right, so Brielle, do you want to tell me about science notebooks and science journals?
Yes. And that's where it might be interesting to talk about too, because I know you've done like the engineering notebooks and how it ties with design thinking as well. But the workshop I was looking at doing is on digital notebooking. So taking a lab or an activity and making it all digital for the students. So I did one on rockets. And so they have to work through each part of it, which I can share my screen so that you can actually see the one I have if you want.
Yeah, sure. As you're bringing that up, I think of, when I say engineering notebook, I always think of it as whether it's something that you're handing the students in individual packets or in worksheets that can arrange chronologically in the end to represent what happened or in the whole design process, or if it's something that kids have a blank notebook and they're recording everything in it by hand from beginning to end. But the idea is that it's something that models what people do in real life to document their design process and their ideas. That engineering notebook in business and industry is something that you submit for like a patent or to defend a patent. And so that language, engineering notebook, is what naturally came out when everybody in STEM would use them, right? In like design challenges.
Mm-hmm.
And so coming from that engineering and technology background and science being a secondary content area for me, I always think of that, it's just like you describe it. Your science notebook is the thing that documents the whole inquiry process or the scientific method, right? Is that kind of right?
No, absolutely.
Right. Yeah. So when I would talk about the two together, I would just kind of say it like the engineering notebook, if it's the whole design process, if at some point in your design process, you're doing an investigation or a proper lab or something where you're doing the scientific method to discover something, then you could consider that as being subsumed into the engineering notebook. The science notebook happens, right? Yeah. So
no, which makes sense. And it's neat too when you talk about it's their notebook to jot down, because so many kids have just sketch notebooks for when they want to draw things. Or I would imagine even for like computers, like some of the kids that do gaming, and like if they jot down any notes, or it's something that's like can be connected in many different ways, which is neat for them.
yeah, I see you're bringing this up on my screen just so I can see the whole thing too.
And this one go ahead.
I was gonna say it's worth putting out there like that too. Like when you go, well, what do you, when I say the engineering notebook or the science notebook, and you think of it, well, kids could have this free place where they're just collecting stuff. If it's a more formal place to collect their ideas or whatever they're doing, right, at the time. To me, when I say engineering notebook, it's like that's also how you collect assessment or how you conduct assessment throughout the whole design process. And maybe you're not hitting a standard at every step of the design process, but you're still documenting the design process properly like you would throughout each step. And if we're gathering and collecting as much of the students' work as we can from the beginning of the design process to the end, including when the science journaling is happening, then we have this collection of evidence that could show whether or not students have provided the evidence they need to show that they've met a standard, a practice-based standard.
Absolutely.
Yeah.
And in the end, they usually end up meeting the standards, even if you think you're not focused on it. Because I sometimes it's so hard when people get so set on, I have to get the standard done, I have to get it done, instead of giving the students the chance to work through it all. And then in the end, they still get the content, they get what needs to be learned.
Right.
So I always did with my students, they built model rockets. And so in order to build a model rocket, they have to go through the understanding of what a rocket is and tying in what they've learned. So they do physics in 8th grade in South Carolina. So they have to tie in what they've learned with physics. They also tie in what they've learned with astronomy, because that's another unit that they work on with 8th grade standards. So the first is just reading about rockets. So I give them an article that's hyperlinked. So the whole thing, because it's digital, I hyperlink all of the different resources that they need for it. So they go through and they read about the rocket, and then they fill in their information about it. I have them create a timeline on the history of rockets. So they go through this article that's attached, and then they actually create their own. A lot of the kids end up using different apps to create their timeline because there's just not enough room in here. So I let them use whatever they want and then put a photo, they embed the photo within it as well. And then I have vocab that they have to look at with it as well. And then further along, as they're going through the different parts, they get to start building. So I actually recorded myself building the rocket in different phases, and then they get to watch the video of how to build it because some kids are way ahead than other kids. So it kind of gives them a chance to work at their own pace. And I've done it with groups. So they'll share actually, no, they have their own notebooks, but they'll work together and then they'll build a rocket that they share. So that's a little bit of kind of what my digital notebook, and then they'll go through and they'll once they start building it, they'll start labeling the parts, getting to know how each of the parts work. This is where the kids are like, do I have to put a parachute in? What happens if it doesn't have a parachute? Because they want them to explode, especially my middle school boys. That's the biggest thing. Can it catch on fire? Can we put the biggest engine in it? So, and then we go through all the different parts, and then they have to put the engine in and they learn about that. And then they go through the actual day of the launch and they launch it. And then once they launch it, they come back and they actually draw out what did it look like when it went up? How did it land? Did the parts work? So they're also reflecting on it. And the kids always worry, am I going to be graded on if it launches or not? And I'm like, no, it's more a matter of you built it and how did everything work? How did everything come together is more the important thing. So this is part of the series, is looking at how to actually build one of these notebooks so that your students can do all of this digitally for it. And then the second part of my workshop has to do with interactive notebooks. So that is more of using a normal composition notebook with it. But do you have any questions about the digital part?
No, it's really nice. And I think this is what is really helpful for a teacher to have, is where you've already thought out the parts of the notebook that will allow you to capture the information and the evidence that you want along the way. And it's perfect because you can, if you have Google Classroom, then these slides that you can just click on that can take you to things can go right into Google Classroom.
No, exactly. And that's what I used it was with Google Classroom, but you could put it into a regular PowerPoint too, if you're using Office, or I know that iPads that they have Google Classroom, the app and stuff, which is nice with it. And what was great is my whole team. So even the social studies, the math, the English teacher, they all wanted to see the rockets too. So the day of, they each took one of my blocks and then they watched a video on how to put the engine in that classroom. And then they brought them out so that I could launch them in the groups, but the whole 8th grade could actually watch each other's rockets being launched, which was really neat as well too with it.
Yeah. Yeah, it's funny you mentioned the standards part. It's like nowhere in the standards as teachers, when we look at them, does it say somewhere that students will have to compete to see who has the best. and the person who students will get an A if they're better than everyone else. It's like,
no, exactly. Like that's the thing. It's like they're learning all the different processes. There's tons of engineering processes in here as well that you could pull out that I don't specifically say it's this one, and that one, which is neat too.
So so this is like, I see that there's a hands-on piece here. There's building a rocket.
Mm-hmm.
It's not necessarily a design challenge because they're building a rocket, they're building a model together, and everyone's
Correct.
building the same model. And then we're using that model to run an experiment and capture back data.
Mm-hmm.
Yeah, awesome.
Exactly. But like you said, it would be neat if you took it into a design challenge of how can you build a rocket, or give them the option of what type of rocket to build. I mean, you could pull in all the stuff that happened this summer with Elon Musk with his rocket, SpaceX, and then also, who was it? Richard Branson that just went to space, and then the Amazon guy just went to space as well. So it would be interesting to bring a design challenge in, connecting all the current events that happened this summer and having them build rockets.
Perfect. It's like that's how I see any good lab in science, or traditional lab and investigation, as being something that should be able to fit into any number of design challenges, where whatever the problem ends up being, we need a lighter rocket, a faster rocket, a rocket that shoots higher, a rocket that costs less, whatever that requirement is, you want them to design a better one for. they still have to, they still would have to do this lab, right?
Correct. To give them kind of like a background of it.
Right, so that you can cite things that you learn from this lab as evidence to support design decisions about a better whatever rocket design would be, and then you kind of reuse this format to some degree again, because you're going to have to test your new design, right? Your solution to the problem once you've prototyped this thing, and you're going to have to fire it off and see, is it faster or better or lighter? And so I can see that investigation and scientific method happening twice within the course of full design process, right?
No, exactly. And do you ever encounter with teachers like, well, how do you find the time to let them do the next step? Or do you give them any way of saying like, okay, you might not be able to build it, but do you have like time to let them? Just wondering if, with all your stuff.
My general recommendation is, if it's something like a bridge we crush or a rocket we fire out where the building time takes a lot of time, then we may, once we test something, we may not have a chance to rebuild the thing and test it again. But if I can go back to my original design and I have to have this redesign opportunity where I have a chance to say, here's what I would do differently in my design next time, and the changes I would make, whatever that looks like, because I expect those changes to result in X, Y, and Z, right? Like my new hypothesis on how I think it should work. And even if that doesn't get to be tested, it is the bottom up, the main opportunity for students who didn't quite maybe grasp one of the standards that we were going for earlier in the design process.
No, it's true.
They may have a better explanation for that thing now, or that after seeing all the testing that occurred in everyone's designs, right? Now I have a chance to say what I would do differently with my rocket, because I've learned from watching other people's things. And so now I have this evidence-based writing that goes with my new design. So I mean, obviously I have a chance to rebuild and stuff, right? And if that's not enough, then people could get a chance to critique my argument for why I would change my design and how I think that would make it better.
I like that. Right? That bringing in
not
like
really,
just the argument.
Yeah, not really testing it. Not really testing it. We're like at least critiquing it up against what somebody else thinks.
And I like how you brought in as well the fact that the student may have not learned it from the original, but by hearing their peers and actually interacting with them, it might have helped them to get to that concept that they maybe weren't getting originally. Because I know that's another thing teachers are always asked about. If you have kids who still haven't gotten the concept, what to do? So just giving them those tools too is helpful.
And is this is this also a full lesson wrapped into this? Because are you introducing like a phenomena at the beginning? Is that what's happening here?
It's
or do
usually
they use their rocket launch as the phenomena that they've
exactly. And we've kind of, the phenomenon would be, I would say, during the astronomy unit, we have gone into different rocketry. We actually look at October skies and talk about that and hidden figures as well. So we've done
so this is like this is one investigation of potentially many in a unit where you already had like a phenomenon that kicked off the unit.
Exactly.
Okay, cool.
So that's it. We end it because I usually will do physics and we'll get into the phenomenon there as well. They actually have to build a car completely out of pasta for physics, and they have to get it to go a certain distance. And it's amazing to see how they think for that one. Because pasta is not an easy thing to build an axle and wheels with, but it's a cheap product to use to like build something. But so they've done that. Then they have done their whole astronomy unit where they've gone into different investigations, smaller labs activities, and then they go into this one as a bigger.
Awesome.
With it.
Awesome.
So.
Hey, I think it should be a challenge when they have these supplies, because if it was easy, there'd be no, what was the point?
No, well, and the best is they all want wagon wheels, and you really can't find that pasta anywhere anymore. Like, it's a harder one to find. But the best part is they use those and they don't work because they're not perfectly like smooth. So it causes more friction. So they start learning that, because I let them test out the whole time the ramp is out in the classroom, and they can take the pasta and test them out on the ramp and play with it, like, so that they really get the opportunity to discover what would be the best way to actually make a car that's going to work.
Yeah, cool. So all that was awesome. Now I'm wondering, so as a technology and engineering education teacher, tech ed teacher, my whole class is design challenges, right?
Mm-hmm.
And obviously, as a teacher, I would always hope that I could do a better job with the investigations that I would conduct in my design challenges, because it wasn't firsthand for me, right? It's something that a science teacher knows how to do investigations really well. So I was going to say, when I say engineering notebook, to me, that's my chance. Like, that's where I'm going to capture everything. Like, I don't know if there's any other assessment I'm conducting anywhere during my design process that I'm not going to say falls underneath engineering notebook.
Mm-hmm.
Right. So everything to me is in there, whether it's formative or formal or informal, or we're counting part of it as summative, or the collection of it all as summative grade at the end. When you talk about being in a science class and we're collecting, whatever we're gathering from as assessment, would the journaling be everything, or is it other stuff too?
So with investigations, it's usually journaling, either digitally, right, or in their composition.
So like scientific method, if I'm going from beginning to the end, my journal captures the whole scientific method.
Correct. Exactly. Right. They're writing it out. They're doing more of like this specific scientific, like where they'll have their materials, they'll have their hypothesis or what their prediction will be, and then they'll go into the investigation part of it. If they're creating their own procedures, then they'll have to actually write those out. Sometimes I give them guidance with it, or they'll have directions somewhere, and then they go through and write out the different data that they collect, their observations. I'm really big about graphing. I feel like students really need to learn how to create graphs. So they usually will have some type of graph in there too.
And that, like, 2 practices off the top of my head, right? To model, to create and use a model. So if I create a graph from data, I'm making a model and also to communicate information. Be a practice, right? So being able to model and we know that the graphs are a thing that the standardized testing relies upon heavily in all 3 math languages literacy.
No, absolutely. Exactly. And then and like you said, the communication, like at the end, they're reflecting both individually and then as a whole class of some type. So that's kind of how I assess through any type of investigation, that's what we're going through, or all those steps with it.
Yeah. And if we were to just keep on going in our long form conversation, I mean, it which would be great for the people that share the same interest in this as you and I. Like they would have no problem wanting to continue on the conversation. Probably it was that, like, if we were going to say now, as a science teacher, they're telling me I have to put design thinking standards into my classroom, right? I could see in your workshop that that's something that could be, without having to say you're covering it, because it sounds like you're not giving enough time, but I think that the standards in design thinking are many of them are so natural that we would see that you could quickly point out where some of the real world problems and issues that deal with rocketry, or why we need to get into space in the first place, or using one rocket versus another, or which company, the standards are just sticking out like a sore thumb.
Exactly.
To go with that, right? Yeah. So it's super cool. I love this. I think it's a great template. And then and right in there as the teacher, whether you have a slimmed down version of a notebook that's kind of generic that you can use for any lab or investigation, or you go into that slimmed down version and you start to craft certain pages like you have here, where what you're going to get the student to put down on there or record or whatever they're going to collect, that then later can stand on its own as evidence to support, to say the student has given me the evidence they need that matches with the evidence statements in the next gen science standards.
Yeah, exactly.
That go with a specific standard. Yeah.
No, and the fact that, and like the digital, like you said, they can record, they can draw, I mean, that's the nice thing, is you're giving them multiple mediums to be able to actually show their understanding as well.
Right. Yeah, and there's nothing stopping you from having a section where if you had to have somebody do something on paper, that they could upload it into a box.
Exactly. Yeah.
And I could even see where these journals had like comments on them or something, whatever, in Google, to like show like this is where we're actually hitting a specific standard. You know, like, and these are the evidence statements. What they would say. Yeah, you'd have no And when you capture this like this too, you're talking about making graphs, right? Like the
Mhm.
teacher can probably output stuff from these journals to say, here's what so many students put here, what they thought for this, and it
That's
would
true too.
allow.
Yeah.
So when I collect something as a bunch of papers, I have to go through, look at every paper. But when I'm collecting digital, I can shoot something to a spreadsheet, and it can tell me very quickly. I can make the invisible things there visible as a teacher.
No,
See
which
what's
is
going
so
on.
helpful.
Well, this is a really nice product, Brielle. I
Thank
can't
you.
wait to be a part of your workshop, and I hope to bring more science journals and good best practices for science journaling and digital science notebooks into the engineering notebooks and best practices for engineering notebooks as well, because they perfectly overlap.
No, absolutely. That's exactly like all of the design thinking standards fit beautifully in there. So awesome.
Cool.